Okay, this is adding and subtracting polynomials. Now, you've been adding and subtracting forever, and what I want to talk about is this idea of like terms, which confuses students sometimes. But when you add numbers like this, you know that you're supposed to add this 2 and this 7 together because they're both in the ones place. That's like terms. You add this 2 and this 1 because they're both in the tens place. That's like terms. And they don't have to be physically in those places. You know right here that you're going to add the 3 plus the 2 because those are ones, and the 4 plus the 1 because those are tens. So think about that same idea as it relates to polynomials, and it should help you understand a little bit more about combining like terms. So just like we had the ones column and the tens column and all, we sort of have that with polynomials. We have the ones here, the x's, x squareds, x to the thirds, x to the fourths, x to the fifth. They're all separate quantities and cannot be combined with others that are not their same exponent value. So for example, I have 4x squared plus 2x minus 7 plus x to the third minus 2x squared plus x plus 8. So I used some colors to indicate that I went looking for the matchers. I saw that 4x squared and negative 2x squared, make sure you keep the sign, those are both x squared terms, so they're good. So I added them together down here. Then I noticed I had plain old x term and a plain old x term here, a 2x and an x, and I'm going to add those two together. And I have a negative 7 and a positive 8 for my ones terms, and I can add them together. This x to the third is just sort of left hanging. He doesn't have any matchers to go with, so he'll be alone. My final addition would be that x to the third, then 2x squared, because I had a 4x and a negative 2x, then a 3x, because I had a 2 and a 1, and then a negative 7 and 8 gives me 1. That would be my combined terms. Okay, let's look at subtraction because it's a little bit more difficult. You have to pay a little bit closer attention. I specifically put in some weirdness with the variables here to help you see that in order to be like terms, all powers of the variables must match. So for instance, if I see 6p squared q, that's not the same as p squared q squared, because this one has a squared q and this one doesn't. This 8q squared can't match up to p squared q squared because it doesn't have the p squared. But the pq and the pq can go together, right? So what would I do? I would bring the ones down that have no matchers alone, and then I would take the pq minus 3pq and get negative pq. When you have a subtraction, this means minus 3pq minus 4p squared q squared. See where the minus is? So I collected those terms down here at the bottom, and the only two I could combine were the p squared and the negative 3p squared, and I did that math, and the rest of them just got listed. We have one here, so you can try it and see if it makes sense to you. Again, it's subtraction, so pay attention to that sign. Pause the video and try that problem yourself. Okay, I'm going to look for matchers, and the only thing I have a 2a and I have an x. This is an x squared, this is a and x together. But this negative 2a and this 2a are both the same kind of term. So I'm going to start with that. 2a minus negative 2a is the same as 2a plus 2a. So that would be 4a, okay? And I have a 7, which didn't have a partner. I have a negative x, which didn't have a partner. Now, this is not really 3x squared because it's being subtracted. No x squareds minus 3x squareds is negative 3x squared. And no ax's minus 4ax's is negative 4ax. Those negative signs are going to become very important. So I think I'll organize this a little bit better by putting that in standard form in descending order. So I'm going to start with my x squared term. And then I think I'll go ahead and put my 4ax, then maybe my 4a, then my x, then my 7. These in here, because they all have an exponent of 1, no visible exponent, it doesn't really matter what order I put those in. What matters is that the squared is going to come before the ones without, and the 7 is going to come after the variable terms. This is what the final answer would look like. If you did not get that, go back and look over the video one more time. Now, one thing that often helps students to organize their terms is the area model or the grid. I specifically did a multiplication problem with it, but the point is, this looks pretty confusing. And if you organize it in a certain way, you can make sure that you haven't misnamed any of the terms, that maybe you haven't forgotten to put a squared where there should have been a squared. I know for exactly that these two multiplied together are going to give me this. I simply follow the box down to where the two column and row intersect, and that's what goes there. So I have 2y to the third times 3p. The 2 and the 3 can be multiplied to get 6. Y to the third and p, though, can't be combined, so I just keep y to the third and p. I come over here, and now I have negative 5y squared times 3p. I can multiply negative 5 and 3 and get negative 15. But the y squared and the p, again, cannot be combined. Will not make a different exponent, so I just put them in there. So I have 2r and 3p. 2 times 3 is 6, but the r and the p just go together like this. And last, negative 8 times 3p, I get negative 24 and p. And then I did the same thing down here for multiplying everything times r. Times r, times r, times r, times r. Then I can look at them. I have a y to the third here and a y to the third here, but this one has a p with it, and this one has an r. That's not like terms. I have a y squared here, same problem. This one has a p and this one has an r, so they don't match. Then I have a regular p, but this is rp. And I have a regular r, but this is rp. Regular r squared. None of these terms match up. So I would list my answer all the way from the beginning, each of them alone. The biggest exponent, the y squared exponents, then the terms with no exponents, and did I do that out of order? Probably should have done my 2r squared next, then my rp, then my all the way down to the bottom. Okay? But so even though these did not match and allow me to combine any terms, what's important is understanding that I was able to keep track of all of the exponents and all of the variables, because the exponent and the variable has to match in order to be like terms that can be added or subtracted.